All right, awesome. Thanks a lot, Oliver, and the scientific committee for giving us the opportunity here, and especially thanks, Oliver, for allowing us to doing this together, which I think is probably the most appropriate way to present a GNPS dashboard. So yeah, my name is Daniel. I used to be a postdoc at UC San Diego. Now I have my own lab in Tübingen. But what is probably most important for you is that I'm a mass spectrometrist, and I'm really excited about metabolomics. So while I love working with the machine, acquiring data, doing some maintenance, I also have to deal with like sample preparation and also, of course, like the downstream like data analysis. And when we now put numbers on this, I think it becomes very apparent that while being a mass spectrometrist, actually most of the time I spend working with like the computer. And I think if we probably all know, or if we've seen, like during this session here, there's like a plentiful amount of different software tools, often like combined in like nice like patchworks of software solutions. So fortunately, after extensive training, I think a lot of us like emerge as this highly like specialized experts, and we mastered the magic of metabolomics data analysis. So yeah, this typically consists of like different steps, like so data acquisition, data inspection, processing, like feature finding, and then like spectrum annotation, statistical prioritization and visualization, and validation, and also hopefully data sharing that allows like reproducibility and like larger scale repository scale analysis. So yeah, in my case, this is a nice combination of different tools. So we use vendor specific software like Excalibur and Qual Browser for like that first steps. And then there's a couple of like open source tools we like combine to then do feature finding, annotation, and statistical prioritization and validation. So now, while this, I think after the years works out really well for myself, when it comes to actually like communicating these results, and especially like validating results, it's already like getting a little tricky. And for example, if I work with a coworker, it became very apparent, especially during the pandemic, when we were all like locked down at home behind our computers, that it's actually like hard to do something together on the computer. And it becomes even more challenging now thinking about, I don't know, being a PI and working with like a larger group where we eventually have different people using different tools and different instrument platforms with different formats. That's already hard to come to a consensus. And the latest, when we interact with the community, I think that's really like a challenging thing to like reproduce results and simply like verify simple findings from a published paper. So yeah, I think this validation step at the end, which kind of like is a bottleneck, and I think different vendor formats, different like non-open source software that you eventually have to buy really like prevents like going back to that original data and verifying like the results. So, and here it's not only like the actual like visualization of the file. So there's like numerous software solutions to open LCMS data if that's in a public format, but also simply the fact that you have to download data to actually like visualize it. And with like growing like data sizes, this I think becomes also a time-consuming factor. And when you think about peer review, for example, I think simply this, I don't know, ranging time of a couple of minutes to hours if you have to like download or even buy software, like really prevents the inspection of raw data, right? So wouldn't it be great if there would be like a simple way to just like visualize data right like in your web browser, right from like a public repository where people like deposited this data? And I think this was the main idea behind the dashboard. And after bugging Ming for long enough time, we kind of came up with a very simple visualization approach that allows you to visualize XICs directly from, for example, a molecular networking job in GNPS, but also from a massive spectrum, and simply inspect like the XIC. So is this data real? How does it compare between like my significant samples? And since then, this really has like emerged and rapidly grown to like actually like kind of like central point of our data analysis pipeline, where we can like first visualize different data sources. So we have access to like multiple repositories where you can directly pull this data into this online LCMS viewer, but also launch now analysis from there. So after you tested some settings, you can like submit, for example, feature finding jobs or molecular networking jobs. And then most importantly, it allows you to share this views, to share this with like your collaborators in a paper, or even like in a live setting in a Google doc style interaction. And yeah, it's awesome to do this together with Ming. So he's gonna tell you a little bit more about like the details and the infrastructure.
Well, thank you, Danny. And well, again, thank you, Oliver, for letting us do this. This is so experimental. We'll see how it goes. But I just want to give you a little bit about just the hardware background and implementation just very quickly before we get to the exciting stuff. But it's open source. You can go and download. It's a Python web server running on our own servers right now, but you can deploy it on your own systems if you want. And we think it's scalable, reasonably scalable. We're no Google, but at least for us, we've been able to work with the community during workshops with hundreds of users or over 100 users, and in classroom settings as well. And it's relatively new. It's definitely a humble piece of software, but we've been able to look at tens of thousands, or the community has, I haven't looked at very much, of LCMS files with hundreds of thousands of actual visualizations and 4.1 thousand users, not 4 users. But I wanted to tell a little story about Danny and how he's been using it, how he's been finding it useful in a kind of a short vignette. And one of the things that he's been analyzing in some of his data a couple of months ago was he was looking at MS2 data, and happens to be molecular networks here, but he discovered, or he identified, a particular putative molecule pictured here called Yersinia-Bactin. And he wanted to ask, okay, is this actually real? Do I see a nice chromatogram in my data? And simply with a few clicks, he's able to go into the dashboard, dive from this high level of a molecular network all the way down into the raw data. And so this was really key for him, because looking immediately right there with the data kind of online, in an online way, he was able to see that this is actually 2 molecules that are diastereomers of each other that are chromatographically resolved, but specifically they have identical MSMS fragmentation. So at least looking at just the MSMS, you could not tell it was two molecules, but revealing it here, it's very obvious. And kind of taking this a little further within the context of his experiment, it was actually a wild type versus a knockout experiment, trying to knock out this specific molecule. And so there are 2 cohorts, and very easily, because we can pull all the data in the browser, just simply looking at what is it present in wild type and is not present in the knockout. So again, speed and convenience and lowering barriers to entry is kind of the name of the game here. And one other kind of small side point to kind of bring it a little full circle is we've integrated with the MZMind team of bringing very rudimentary, your first pass feature finding into the dashboard. And so just to make things a little simpler by reducing parameters, but given some of the talks we've seen, this is not to be the end all be all kind of thing. It's simply to get new users to these software platforms to get started. But going forward, and definitely after Yasin's talk, and he's joining the lab, we will need his help to start asking how good is this feature finding. And then also one of the things that you can do in the dashboard is if you have MSMS in your data and you're looking at it, first of all, you can inspect it, and that's par for the course. But some of the work with Nuno Bandeira and Ben Pullman is we've integrated real-time library searching into the GNPS dashboard in addition to real-time repository searching. So you can ask, has this been identified before? And have I ever seen this spectrum in all public data in a fraction of a second? And actually it tells you the number of hits and asks this question before you even click on the button. So it's kind of this prefetching idea. But so that's all par for the course. But what's really exciting and what's unique, one of the things that you uniquely do because it's running in a web browser, is that we've built out the ability to seamlessly share data at multiple different phases of research. And so I just want to outline in the first phase, when you're actually going through the data analysis with collaborators, with supervisors, with mentees, it's making that easy to share results, to corroborate data analysis. The big payoff here is you get more bites of the apple and iterate on the data analysis to be more confident and make newer discoveries faster. And the second phase of the review phase, when you are publishing and getting journal reviews, making it easy for reviewers to actually validate your data, reconfirm your results. This has big payoffs in checking that, number one, the data was made available properly, which is a huge, huge thing. And also it'll hopefully improve manuscript data quality. And then finally, at the very end of post-publication, once the paper is accepted, hopefully the data is deposited, with the GNPS dashboard, we hope that it simplifies data reuse. So you can reanalyze data, reinspect it, and in our experience, it has really improved the teaching of MS data analysis and visualization that enables students to view across multiple different instrument platforms very, very easily without installing specific software for each one. And so I wanted to just take a step back and talk about how we're thinking about data visualization and just give you examples on how we're tackling each of these. And so there's two dimensions in my mind. There's data sharing across space, and there's data sharing across time. And so space is, you want to look at data together, but you're not physically present, something most of us are familiar with over the past 18 months. And so this can be with a collaborator, a mentee, or in a classroom. And so this is, we call broadly synchronous real-time sharing. And then there's other times where you want to share across time. And so this can be yourself. I don't know how many times I try to refine data that I looked at a couple months prior. So this is, a service to myself. And then also with a collaborator that you want to email a link to that they can look at their own time, as well as sharing the visualization for a journal reviewer. And so this async, and what we call asynchronous data sharing. And so this particular problem, one way we've solved it is whatever you're looking at in the GNPS dashboard, you can create a shareable URL that captures everything in that visualization. So if you all have your phones out and want to try it, you can scan this QR code and try it out. But by sending these URL links, you allow others to see exactly what you're seeing in this specific moment. And so if you miss the QR code, there's one at the end, so don't worry about that. But the really cool part to me that we've built out, and Danny alluded to this earlier, is this real-time synchronization. So the way we kind of convey this idea to others is Google Docs, but for mass spec data analysis. So you type in your Google Doc, you see the change, everybody else sees the change immediately. And so this is one of the things we've enabled in the GNPS dashboard. And then the first mode is this leader-follower synchronization that we think is great for a classroom teaching. So there might be a teacher or some sort of instructor, and they want their students to follow along in real time, and it can be 50, 100 students. But the real key here is the instructor guides them along in the data analysis to a certain point, and they can stop syncing at that point, and then they can build upon that visualization themselves. And finally, the ultimate mode on this kind of synchronization that really mimics Google Documents is this full synchronization. And so you can imagine a small group of researchers looking at some data. One researcher changes the visualization, zooms in on the chromatograph a little bit, and that's immediately reflected for all others. And this is bi-directional. And so generally, this is meant for small groups. Doing it in a classroom, highly not recommended. But we think it's really cool, and this is hopefully a new way that people can collaboratively and remotely analyze data together. And so I want to kick it back to Danny so he can tell us how it's changed his way of interacting with data visualization and how his lab conducts research.
All right, thanks, Ming. So yeah, coming back to basically where we started, looking at our work days as mass spectrometrists or metabolomic scientists, I don't think that that's going to change much, but rather like probably going to shift even more like on the computer side of things. And yeah, we hope that with the GNPS dashboard, we can at least like facilitate that communication like between like coworkers, between small groups, but also between like us and the community at large. And yeah, I hope that the dashboard empowers more collaborations that way. I hope it simplifies teaching, like and showcasing of data analysis with like a classroom, for example. And I hope that it will like facilitate like accessibility of raw data in the review process, and hence like advocate for data sharing and data transparency, and hopefully puts like data sharing to the next level. So with that, we want to thank everybody involved, especially people in the Dorstein and in the Bandera lab, and Vanessa Phelan in Colorado, and all our beta testers and co-authors of the GNPS dashboard paper, which also was just accepted. So again, if you want to try it out, here's the URL and the QR code again. And yeah, we would be happy to take any questions.
Thank you so much for your energy and your presentation. That was great. I already have lined up questions here. Shen, come first.
Hello, I'm super interested. Thank you for the tool, because usually before I'm so overwhelmed with the hairball structure and don't know how to interpret it, and publishing that or reviewing those papers is hectic. And this is, for me, is like ground step from 0 to 1 to be able to use it and visualize it and comprehend it. So now I'm thinking about from step 1 to 2 now. It is going to help with data sharing and validating each other. But how do you think that the implementation to be able to index across different studies, saying I'm seeing this conjugate in this bile acid and in a different similar study? How do you see that similarity, or just by name? Or usually those structure similarity has several candidates, not always the top one hit will be the accurate one. How do you solve them ambiguity, maybe loosen it up a little so that you can easily show the overlap in cross-validation?
Thanks a lot for the question. So first of all, I think the connection between like data and your study needs to be like connected somewhere. So for example, in your manuscript. And then for like annotation, I think here we're not actually like going that far yet, right? Like to communicate confidence in MS annotation, for example, but going like to like really like low level questions, like is the right MZ within like a certain like error mass found in your actual data, right? So is that the case? How does the overall like structure of your files look? Did you use like dynamic exclusion, for example? And you can like see that actually really quickly by like looking at the raw data. So I think what you describe, I think that's probably like the next step. And here we're like even like a farther like upstream.
All right, I have a second question over there.
Great talk. I have it might be kind of silly question, but is that possible? Like when I'm searching my spectrum, is that possible to find some of the spectrum that has been acquired from same analyzer that I've used? For example, like if I have a data from QE+, which was based on Orbitrap, can we actually find the spectrum that has been acquired from Orbitrap in GNPS dashboard?
Do you want to take it?
So yeah, great question. This is kind of broader than the GNPS dashboard. And kind of you have some spectra on hand. So one of the tools that we built out, actually, if you went to the Beeman lecture last night, you would have, anyway. So one of the tools is called MAST. So if you have spectra that you want to ask, have I ever seen this spectrum before, specifically on Orbitrap instruments, you can ask broadly that question using the MAST tool to find it across all historical public data out there.
Thank you.
I think Shen has a follow-up question.
It's a different one. This is like the front end visualization, which is awesome. But if in the back end, the algorithm cosine score in the back end of GNPS calculating the networking is different. It's changed, improving. Would it just upgrade everyone's dashboard visualization so everyone is on the same page?
So I think it's not really like based on like identification. While you can do that as one of the functions, right? It's not like retroactively like annotate your data. So I think it's really just like at the first place fewer. So I think you bring up a very interesting point, and that probably goes more to like the processing pipeline as a whole, which includes, of course, like spectrum annotation. And I think in the long run, it would be awesome to kind of like unify that as well in a reproducible way. But I think we're not like fully there yet, at least with the dashboard.
Just to follow up on this, yeah, in GNPS, we have analysis workflows. And one of the things that we specifically do is all old results do not get upgraded. And that's a feature. It's for data provenance, so it's reproducible. But when we do, and if you want to work together on improving tools, let's talk after this. But as we move forward, we version everything. And so if users come back and do a reanalysis, they will get updated results more in general.
Okay, thank you so much for the two of you, and congratulations to your Nature Methods paper.
Thank you.